Okay. Next step, design of welded joint. In case if it is given to design as welded joint, we should design the welded joint for slab base plate. Otherwise, right, providing 2 to 4 bolts of or rivets to join the concrete pedestal to slab base. If in case it was given to as design welded joint, we have taken the welded joint. So like this. So this is the ISHB 350 section, and this outer line was slab base plate of 420 by 420 mm. 420 by 420 mm. So this is the width of flange web, and this is the flange width 250 mm. So here, how much the length available for welding? So already we have discussed the length available for welding in first chapter, welding. So length available for welding was, so total ISHB section we have to weld it. So how much distance? So total length means 250 plus 250. So this is the 250 plus 250, two sides. So 2 into 250 plus 250. Why 250 plus 250 plus 250 plus 250? Next 350. So height. This is the height, 350 plus 350. 2 into 350. So but here these gaps was not welded. These gaps was not welded. So we are subtracting minus 2 into, this is on 10.1, 10.1 minus 2 into 11.6, 11.6. So this is the total length available, 1656.6 mm. So this is the length available for welding. Next, end returns. So we know we have calculated the end returns in first chapter. End returns is nothing but how many ends are there for welding. So 1, 2, 3, 4, 5, 6. So this side 6, that side 16 numbers, total 12 numbers. So we have taken some size of weld, that is 3 to 10 mm. So 3, 5, 6, 8, 10 mm. So I am providing 8 mm size of weld. 8 mm size of weld, and you know how to calculate strength, that is LW into TT into FU by root 3 gamma MW. So TT is nothing but throat thickness. We have know how to calculate 0.7 into ES. So calculate and write down the strength value. So length available, length of weld means this is the length of weld. Okay. So last system, design of concrete pedestal. As we know, we design the slab base plate. So upon this, we will design concrete pedestal. This is the area for concrete pedestal we should provide. So we have provided slab base plate. So the outer line for slab base is concrete pedestal. Concrete pedestal. So this is the concrete pedestal means. Okay. So how to design the concrete pedestal? So first step, axial load. Calculation of axial load. So axial load is equal to factor load by 1.5. Factor load by 1. So we have now factor load 1500 by 1.5, that is 1000 kilonewtons. 1000 kilonewtons. Next, total load is equal to axial load plus self weight. Axial load plus self weight. So here axial load we know 1000 kilonewtons, but self weight we should assume. So first step means assuming self weight from 10%. So we should start from 10%. But for this problem, 10% we have assumed, that is concentration which is not safe. The design will come which is not safe. So I have done from the assuming 20% only. So directly 20%. So if you do the problem, do it for first for 10%. Again redesign from increasing the value of 10% to 20%. So assume 20% of axial load. We have got the value of 200 kilonewtons. Therefore total load, axial load plus self weight, 1000 plus 200, we get the value of 1200 kilonewtons. We get the value of 1200 kilonewtons. Second step, area. We have known the formula of area, load by safe bearing capacity. Load 1200 by safe bearing capacity, already we have given the value 200. If not, assume from 200 to 230. 200 to 230. If not given the safe bearing capacity value, assuming. If given, what is the value given? So substitute the value and write the area. Okay. So we have got the area value 6 meters. Next, size. Same, root 6, 2.45 meters. Depth half into capital B minus small b. So capital B is nothing but concrete pedestal area. Width small b is nothing but slab base width. So capital B 2.45 meters. Okay. Small b slab base 420 mm. But here we are writing 2.45 meters. Next we should write the value of slab base also meters only. So I have written the value 0.420. So half into 2.45 minus 0.420. You get the value of 1.0 meters. So safe load I am providing area into depth into density of concrete. Area we got the value 6 into depth 1.015 into density 24. We get the value of 146. So this safe load must be less than self weight. This safe load must be less than self weight. Otherwise it is not safe, and we should redesign the problem from axial load. We should redesign the problem from axial load, which is increasing of assuming percentage of self weight. So providing 2.45 by 2.45 by 1 meter size of concrete pedestal. So this is the concrete pedestal and this is the slab base design, which we will get for 28 marks. 28 marks. Okay, this is the very important sum, slab base problem. So first step area, bearing strength of concrete. Second step area. Third step length. Fourth step intensity pressure. Fifth step thickness TS. Sixth step welded joint, and eighth step is design of concrete pedestal. So same problem, same methods. Okay, so this is the main problem of design of slab base problem. So I have kept the PDF in your group. So please listen to the video and write the problem. If you have any doubts, we will clarify in doubt class. Thank you.